Hello, everyone. Uh, Welcome to workshop 5. Tia, are you going to make an introduction, or should I?
Oh, you can go ahead.
Okay. So I hope that you are doing well and ready to get to the seminars. So how are you doing?
Good, thank you. How are you?
Good. Thank you. That's great. So let's get to the today's topic. It's great. So today's topic is about data-driven and keyword-driven testing, and I will say a few words. What is it about? And afterwards, traditionally, as we had in last previous seminars, we will have some practical examples about each, some very basic examples, and then we will have we will implement those kind of that we learn during basic examples to test our simulator. And so um, about data-driven testing, what is it about? It's about basically separating data from the code. So that means that code in this example becomes, we can use the code multiple times with various kind of data that can be introduced, for example, from outside sources like databases, like we will have it on today's examples, or for example, also some external files. So this is this is a very big benefit during test automation, which this approach provides. And so, but in order to, the drawback is that making this code to make it flexible enough to for it to be able to receive a lot of kind of data is time consuming. So to make it flexible enough to for it to be able to do all that. But once it's done, and we will see how time consuming can be during these examples today. But once it's done, it becomes very efficient. So basically, a lot of tasks, a lot of testing tasks can be automated. We won't need to do them to write the code for every new data that comes. We'll just reuse the existing code. About K-driven testing, keyword-driven testing, its logic is basically to divide tests from into keywords and methods. So then the keywords will be mapped with methods, and also it provides some automation that with just using short keywords, we can reuse the code. So the big benefit in this case is that it's very user friendly, so it's not required to have a knowledge of coding. So inside, for example, teams that have non-coding personnel and also coding, some people that know coding very well, in their cases, they can work together. Like, for example, people that know product well, they can invent and prepare some testing scenarios, and people that know coding can work on implementing those. And this just removes the bottlenecks from the team, so it's very efficient. Actually, I'll now share document I provided a lot more examples of what is the difference, like just what these two approaches are about, and like many other differences and scenarios when they are better to be used. And you can, that's for the further reading. Okay. I hope that you'll be able to open this document and there will be no sharing problems. I see that you did open. That's nice. Okay, this basically includes short explanations, and then there's a useful link that also, I'll show you what it does. Basically, it has content, for example, what is testing frameworks, like benefits, different types of testing, and so on. You can also do further reading about it if you have interest, of course. But today we will focus on examples, how they work, and it will be, I think, a more easy way to understand like whereabouts and how they can be implemented. Okay, and after that we can I can provide all the practical files that will be used in this example. So let's get to our coding program. We will be using again Gherkin, the same tool that was explained in the previous seminar with Levan, because it provides us both ways to both demonstrate all two scenarios, data-driven frameworks and keyword-driven frameworks. So in this example, can you see, by the way, the screen?
Yes, we can.
Yes.
Okay. So in this case, we'll have just the scenario that in theory is user-friendly, so it doesn't require any coding. So we'll just remove this, just comment this and focus on this part, and it will contain, you know already how this works from the previous seminar. I'll just add stuff that is the topics of today's seminar. So in this case, we will have a scenario with three steps. First two will add numbers, two numbers. For example, they can be from the first case, for example, but we won't use this table for now. We will have just add two numbers, 2 and 3. And then with the third step, we are going to check if what we added in the first two steps, if the addition is what we provide in the third step. Okay, this is basically the scenario. It's written in human understandable language, not programming language. So now it needs to be mapped. Functions of how they work to be mapped in programming language. Okay, so for that. You probably remember from the previous seminar that this all needs to be in the features folder, and the coding part should be in a steps folder. So let's create a file here. Let's call it add, and extension should have probably remember py. So it's a Python file. So basically, I will do the writing of the code step by step. During it, some errors may arise, of course, to make all this the function basically to make flexible and to take all the kind of data. For example, here we have minus not only normal numbers but negative numbers. We have like not full numbers but like different kind, and we want to make the function flexible enough for it to be able to take all kinds of data. So of course we will start by step. First, it will not work on all kinds of data, and it will have some errors. Like on each step, we will try to fix them. And I think also that this will provide us some insights of how to work with errors and how to fix them, because sometimes like error can be very easy to fix, and it's important to know how to analyze them. Okay, so let's start with implementing. What we need to define methods for each keyword. So let's start with the first. I'll just type it and explain afterwards what I'm doing. Well, this part you already know, so probably I won't narrate this much. Yes. So this part, I'm not sure if that was covered in previous seminar, but in order to get numbers that were inputted by non-coding personnel, it can be expressed in the functions like this. Then there comes the default method that executes the steps. It will be it needs to have this argument to get this context, and also needs to have a second argument to get this variable. So now what we need to do is to basically what we are doing here is that this is the same keyword that this, and so we can reuse the same keyword, and we only need to define this only once, and it can be reused. So in this case, because of this reason, it basically demonstrates that one keyword can be reused with this function multiple times. It's already some kind of like less usage of our code. But in this case, we need to store these numbers that we get somewhere. So I think a list is most easy way to do it and simple. So let's store it in the list. We know how to define lists already. We need to have an empty list first, and then we probably know how to add elements to the list. And now it will be in this variable that was here. Okay, I think that's all for the first key. It will be used 2 times, and now we need to define this one. We don't need to copy that here. Just it will be easier to copy this. Just substitute the name. It can be n, doesn't really matter. Okay, and so before we continue, we just want to know how the first step was executed. So the good way to do it is by accept. You probably remember from unit testing this word, but it was used with some other words like assert great, assert true, but even that unit test methods in core use this assert statement because what it does is, because this is a testing method, it assert, what it does is if it's what follows is false, then it gets interrupted. And whatever follows can be printed. So we can now print A to see just how the first step did. It's very good for debugging. So let's do this right now. And all we need to do is type behave here. Remember, it says that everything passed, but we don't know what is happening. So a good way for the debugging is to use this extension, no capture. This enables us to see all the errors, like what we want. But in this case, it doesn't work. Maybe I forgot to save it. Let's do this. Okay. So one other thing, like in this case, in order for this scenario to have to use this table, it needs to have this scenario outline name. But if we don't want it to use anything, no table and just this, then it needs to have, no, it doesn't need to have this extension. So let's try again. Okay, so we have some first error. And
Alex, I think there is one extra curly brace in after n in check result.
Yes,
Yeah.
yes, yes. So that is exactly what this error, by the way, told us, that there is some error. This yellow kind of error means that there is some naming errors in scenario and in here. And by the way, I will make some errors like on purpose, so that it will be just we can understand what happens in kind of errors and what kind of errors we get and how to fix them. Okay, I think there was some other kind of error. Let's see what was it. What's the problem? So this is not the problem. Let's see what else is. Let's type it from that. Okay, so as you see, here is another error that I didn't change the t here. So we need to define first function, first keyword, and also this one. Let's see what happens. Okay. Now we get some other error. It says that A here is not defined. So what it means that when we introduce A here, the list, it is inside a method. So this means that outside of method, it's only visible basically here. So in order for it to become visible here, we need to make it global, like that. And now it will be visible, I think. Okay, and here too, okay. So it knows that it will be like it's the same A everywhere. So it doesn't like A. Okay, let's put this here also. So now we have some other kind of error, but now it basically shows that the first step works because it returned the list that we wanted. 2 and 3 were added. Now let's introduce this result and have some checking. Okay. So we leave this A here because it's needed, and for addition we will use for loops. I will just type it and then explain what I did. So in this case, basically this is the way for loops work. Not the only way, but one way of how for loops work in Python. It has very simple logic, so it will loop inside this A list number of times that it has elements, and each element will be assigned to I, and then we can add I, each element, to this temporary variable. We need to, by the way, also define this temporary variable, so it's 0. Let's see now what will happen and run this again. Okay, so now what it says, this is the error, by the way. So what it says that one is string and one is int, and we are trying to add int to a string. So we remember that everything that is inputted from here, the user side basically, is a string. So we need to translate into numbers basically to make some calculations. So what we do is what is asked for us to make this integer basically. That is the meaning behind it. Okay, so now we can actually use like we can have both n temp and a here. Not a but n to compare them. Okay. So let's troubleshoot what happens now. So basically, one is n, and the next is so let's actually compare these two. So now the error is basically that this string, this is also string, so we need to also translate this into int. And this is also int, needs to be int. Okay, so I think this did not need an int. Okay, so all steps now are green. That means that the test worked. So what needs to be now focused on is that in order to just make sure that this really worked, we can make this artificially negative statement and see what is typed. So in this case, we'll also do this. We actually see that these two results are equal to each other. So just this example is done. Now we can move to introducing this database. So how to do it? Basically, initial state was like this. And what needs to be changed is basically this name needs to be added for it to be able to use this table. Then for each column has some name, number 1, number 2, and the result. And these can be used instead of numbers, and it will just take at first run these 3 numbers, then at the second run these 3 numbers, and so on. So let's run it now. Save it. By the way, it's important to not forget saving, because it can be sometimes easy to forget. So what we get so far? Okay, so we are here. We left this not sign, so let's delete and try again. So, so the first scenario worked, this one, but the second didn't, because if we compare, like first example, the summation is 6, and why do you think it is? Can you do you have some ideas? No? I guess I can continue. Because at every run, we didn't empty our list. So all we need to do is to empty list here. We need to A and just empty the list. Okay. Now what happened? So the first 3 worked. To make sure, we can just do this, not, and we'll make sure. So first worked, second worked, third worked, and this one didn't work. So why? Because it has not full numbers. Integer only works with full numbers. So all we need to do to have some ideas, maybe. Yep, that's right. Aynen. Make it float. Maybe I did some kind of error. It was even this is not here. Okay, most scenarios worked, but this one didn't, and this needs to be, it has comma, so we need to do is replace here all the points with comma, so replace. So all results now are working. By speaking from your answers, I think that you're following everything, and everything is clear. So far.
Yes, but only this last part. Float, replace. What did we do now? The last one.
The commas.
Yeah.
But all floats. What did you?
I mean, what did we do? In it, I replace, then comma. I didn't see what changed.
Okay, so as we see this in this scenario,
Yeah.
some numbers have not 2.2 but
Ah,
2
yeah, yeah.
comma 2. So there is an error in.
Okay, okay, okay. Thank you.
Yes.
I
So this
didn't
gives
see.
us this gives us basically we make the method flexible to work all kinds of data.
Uh-huh,
Maybe some can have commas, some can have
uh-huh.
points, and yeah.
Yeah, yeah, I didn't see it was different. Okay, thank you.
Okay. So now I guess you don't have any more questions regarding that, right? Okay. So now to add something to this, what we already did is to to focus on this document. In this case, we define here keywords with methods and also do some calculations. And it's not a good practice because we will see when we will test our simulator that if we include all that stuff that needs simulator to work, for example, like preparing states for cars, like connecting to the simulator and like making moves and stuff like that. It's a lot of lines, and then it will not be clear like which part of this document is just for key definitions and which part is for calculations. So it's a good practice to move this calculations part on a separate document and to have only key definitions here. So let's do this now. And also probably it can be done just same way that here without classes, but we will see that classes make life really easier than not using them. It's related to object-oriented programming. So let's use classes basically to clean this up a bit. So we'll create one more document inside steps also. We'll call it calc, also pi. We won't touch these for now. Scenarios are good as they are, and we'll just work with to clean this up a bit. So by the way, I included on the previous seminar with unit testing some class and method examples. Did you have a chance to look into it?
I couldn't hear the question. Sorry.
So in the previous document of the seminar, I included.
In unit test?
Yes, in unit test.
Yes.
There was an extra section, and
yes.
So I think that was on purpose. Now we'll do some actual practice with classes and objects, and it will be helpful if you did. So let's define our class. It can be called class, for example, addition. It can have a method. So we need our object of this class to have as default this list because we want to remove all the data and all the calculations from this file. So for that, it needs to have a list by default. And for default and automatic actions in classes, we have a special kind of method that looks like this. I will talk about this self-argument in a minute, but for now, just leave it. And it will just have this list. But instead, it will refer as self-A because it's part of the object. That's all for automatic stuff. And next, we want to have some way to do this part. Okay, and def We can call this method add number. It also, all methods of the class have self, by the way, as an argument, and we can have n as a second argument to have a number of addition. And then the same thing basically here also, just self. Okay, and nothing else. And one more stuff for this. Get, or just can be just sum, because we use it for addition, nothing else. So it will do all that stuff, and temp also. Just needs to have intendants and spaces basically. And like this, and like this. Instead of A, we'll just use self A. Here also, okay. So this part is done. Looks like done at least. We'll find out for sure when we run it to have if we have some errors. So now we will not have this. Instead, we will just import this file. Import calc. Now instead of this, we'll have add number. This one. By the way, we can have defined the object of this class here, but as we agreed to just leave this document out of all kind of information, then we can have this object here also, and we just refer to with the file with the full path. And this will have a path like this. So it's a full path. So calc, then example, and inside a number. Then this seems to be done also. Now let's clear this one. And here we won't have anything basically. Yeah, we forgot one thing, to return temp here with this method. So we won't have anything like this, and instead we'll have this one. Example and sum. Let's try it, and it seems to work. We can here do this not to see if it really works or it just behaves that it works. Yeah. Seems like it. So, do you have anything that you wonder about these classes, how they work? Is everything clear? Okay, good. So basically we are done with the first example, and now we can see that it's, I think that this document looks a lot better than when it has some calculations, and the difference will be even more like very apparent when we add simulation stuff here. And now let's move exactly to the simulation. Let's test the simulation. So let's do basically, I'll prepare the same collision test that we used and explored in unit testing example, because it's very familiar for us. Every part of it is basically we know how they work, and it will be I think, convenient to just focus on the new stuff or the topics of this seminar instead of getting some too much unknown, I think. Okay. So let's add a scenario of that. Okay. Now this is a scenario for that. And here. Let's first see what the collision does. Like for that, we need to actually enable our simulator. And let's see where it is. I'll try to modify this one because it's so it is like this. Let's also make it smaller so that everything is visible. So it requires entering, clicking enter to start. Then there are two cars, and we get some kind of errors here. We remember what they are, right? First is the initiator of the hit. The second is sedan, like the stuff that was hit. And then there is like place on the simulator where the hit was. It didn't stop, it continues, so we can hit like another car here, bus, and it will show that it's bus that got hit now. Yes, school bus. Okay, so now let's modify our case so that we can test it. Let's work in the same kind of directory that in here basically. Let's add another class. It can be called collisions. Just collision. We can have same list because we need to put this collision somewhere, right? But in this case, let's call it collisions for more clarity. I think this is the way collisions is. Yeah, collision. This function is done. Now let's get to the adding collision. Add collision. Now basically what our scenario will do is we can provide cars like first car, then NPC, for example, some second car. It will make some collision, and then as a result we can have like names here, and what the callback returns to us should match what we gave basically. That was the one way also, if you remember how unit testing tested in the templates. This case, they also tested if the position of the map was right, but we don't need to test all of it. If we test just one aspect of it, just names, I think it will be enough to demonstrate how it works. Okay, so now let's get back to here. Yeah, it's ready. So let's copy all that and just modify some parts of it. From here, just import needs to be outside of class. The rest of it can be just indenting, so spaces here for them to be part of the method, not part of the class. Not even class, but just file. So 1 and 2, I think it's enough, right? Yeah. Okay. I think parts of it is already known. I don't need to explain all of it. So just we need to remove some of the unwanted stuff. For example, we don't need the second car, so we can safely just comment maybe sedan part. We can use this sedan for the second scenario. This part also. So we need to add here our collisions. So collision and append to append this basically. It now in this case it just prints in the terminal, but we want it to have in the list so that we can test it with the scenarios. Okay. And now we need to stop the simulator because it just runs and runs. We don't want a lot of collisions, just one. Stop. And we need to also close for it to be able to run several scenarios at once. If you don't close, it will just run first one and get stuck. That's how it works. So we don't need to input anything for it to run. It will, when we run the test, it will run automatically. And let's comment this also. So I think it should work. Now we need some way to return the same kind of function that we had in this case. Getting like this kind of stuff. Yeah, let's do that too. It's for the second step of the scenario, this one. Test it. I always forget this word. Yeah. So it will only have self, and it will return. It will have a stamp. Is self collisions, and it will return this stamp. And here it will make the list empty. Basically, it's the same logic. What else we need here? We need here to add self here, that is method, and also car and NPC, because we are providing this car and NPC. So we'll just use this instead. This is the place where we initiate the ego when we basically make our car, the ego car, appear on the map. So we'll just give the name of our car like that with a method. And here it will be NPC. So I think this is done. We will see for sure after running. Now let's add this part. Copying is not always a good idea because these keyword-driven tests are very sensitive to names, and sometimes during copying, even one like space can make a difference and code won't run. But hopefully, you'll have enough time to make this test run during today's seminar, what the time we're given. Okay, so now let's use, I don't need this anymore, and let's use this. I'm not explaining because I think that you already understand what I'm doing here. If not, you can also, of course, ask. Okay. So all we need to here, or we forgot that it needs to also have this object here of our class. Just like this. So now all we need to do is start this. So call example 2. Now add a collision with car and NPC. That part is done. Now this basically is not needed anymore. Not here. And here we need to do this. Okay. So for now, let's make it false like that, just to understand what kind of stuff gets printed. I think we need to turn on the simulation, so let it turn on. Let's see what happens. I think the simulation got a bit stuck. Sometimes the video card overheats, so it needs some time. Okay, it's up already. Let's see how our test works now. Okay, it still requires the simulation to run for some reason. Let's see what error we did make. Yes, basically, I think I know what's going on, but I'll tell you in a second. So it runs, but does not initiate any kind of screen here. So let's look over again. So I think 1 hour has passed. We can, of course, let's look a few seconds more if we can troubleshoot. If not, I have, of course, already ready code, so we can test it with that and go on what went wrong here in the terminal chat. So let's look for a few more seconds or minutes. The hard part is that sometimes it doesn't give a definitive answer to what went wrong. This part is not needed, so just remove it. Yeah, I think that it's a problem with the simulator, so I'll just restart it, okay? So it was a problem with simulator, basically. We did everything right, but so that's what it does, basically. Two scenarios with different cars, exactly the same way, like this. So first example, it uses Lincoln, and second example, it uses Jaguar and sedan, and the first one is school bus. Okay, so the one part that was different before I added this, I copied the already working code, is this part, is basically testing of both what we get. So this is the only difference. And the part that I added here in the calc, that by default it didn't run, so I added this part here to run it, for the car to move by itself. So basically that's all I wanted to cover during today's seminar, and I already included the document in the chat area, and I also will share this document with all the files and documents here. So and also the homework will follow in very soon, in a few days. And do you have any questions, by the way, about this? What was going on there?
It got hard for me at the end, so I'm gonna watch this seminar again and try to understand better.
Okay.
And I will ask in Telegram.
Of course.
Thank you.
Okay, thank you. I'll stop the recording now.